Okay, so for question 2, once again, we have a binomial problem. We're told that a surgical procedure is successful with a fixed probability P, and we'll assume this procedure is performed 5 times and the results are independent of each other. So once again, we have binary outcome, success or failure, independent trials, fixed number of trials, and a fixed probability of success. So binomial. Right, so let's once again define our random variable. So let's let y be the number of successful surgeries. Right. Then we know that y is distributed binomially with, now we're told that there are 5 trials, right? And we know that the success probability, is p. Now I'm going to put p in there for now because for a, b, and c the value changes. So that's our setup, binomial variable, 5 trials. So let's have a look at A. Here we're asked, what is the probability of 5 surgical procedures being successful if p is 0.8? So first of all, let's consider y binomially distributed with fixed number of trials 5 and probability of success 0.8. Then we can find the probability of 5 successful procedures. So we want to find the probability that y is equal to 5. The random variable is equal to 5. And just as in question 1, we're going to use the definition of the probability mass function. So 5 trials where 5 are successful, probability of success 0.8, and there are 5 successes, probability of failure, and there are 0 of them. Now, what you'll get if you put that into your calculator is 0.3277, and once again you can use R for that. But look at the tutorial solutions for that. Fantastic, so that is the probability of 5 successful procedures if there was a probability of 0.8. Now, next question says, what is the probability of exactly 4 successful procedures if probability of success is 0.6? So, once again, in this part here, y is binomially distributed with 5 trials, probability of success 0.6, right? And we want to find what's the probability that y equals 4. So, once again, we're going to use the definition of the PMF, and we're going to take 5 trials, choose 4 successes. Probability of success, in this case, is now 0.6, and we want 4 successes. Probability of failure is 0.4, and there is now 1 failure. And if you calculate that, you will get a probability of 0.2592. Now, in the so that's the answer for part B. Now, part C. Now we're looking at the probability of success is 0.3, and we want less than 2 procedures being successful. So, y is binomially distributed with 5 trials, probability of success 0.3, right? And now we want the probability of less than 2 being successful. So we want the probability that y is less than 2. Now, we don't want to have less than, we want less than or equal to. So that's equivalent to the probability y is less than or equal to 1. Alright, which is equal to the probability that y is 0 plus the probability that y is 1. Move that up here. Cool. So now we can find those 2 probabilities. So we have the I don't know what that was. So we can write them out using the definition of the PMF, right? So for 0 successes, we have 5 trials, 0 successes, 0.8 to the power of 0. 0.3. Oof. Right? And then this probability of failure now is 0.7 to the power of 5. That is that thing, the first term, right? And now the second term is going to be 5 choose 1 success times 0.3 to the power of 1, 0.7 to the power of 4, and now that is this probability. Okay, and now if we add them up and evaluate them, you will get a value of 0.5282. And that is the answer to C.